today. So hello everyone, and we have the next lecture. It's lecture about Greeks. It's interesting. Greeks in financial mathematics, but previously on stochastic financial mathematics. Um, we formulated the main aim of our course to model financial market. And what does it mean? It means that we would like to model riskless asset. It's just to define interest rate. And we chose geometrical Brownian motion, GBM, as model for risky asset. You remember this, yes? Where W is Brownian motion, Wiener process. Brownian motion or Wiener process is the same. And we can denote it as W, T, O, Z, T, O, B, T, B because it's Brownian motion, W because it's Wiener process, and Z you can solve. After that, we used ita lemma to calculate the differential from f, where f is some value function of co-option. So you see on this slide how we apply Imaleta to geometrical Brownian motion. The next step, we build the riskless portfolio. You remember on the previous lecture, yes? And this portfolio, it's as a vector. He has two coordinates. The first coordinates, it's number of stocks, and it's number of options, and this number is -1, and minus means that we not buy sell. The second coordinates is df respect to ds, and it's amount of stock. After that, we can compute value of portfolio. How we can compute value of portfolio? Amount multiplied price plus amount multiplied price. So amount -1 multiplied price f. Now we don't know this f, and amount of stocks multiplied s, and we know s. S is initial price of stock. After that, we assumed that for this portfolio change delta P is proportion R, P, and delta T, where R is interest rate, and we arrived at a celebrating that shows partial differential equations. And you can see on this slide these partial differential equations. Maybe you can mention that this equation it's not stochastic, because this equation doesn't contain Brownian motion, yes, or other variable or other random variable. So for this equation, for boundary condition f equals max s minus k and 0, we obtain Black-Scholes formula for fair price of call option. In this way, we can estimate the premium of option. And this formula now is known as Black-Scholes-Merton formula, Nobel Prize in 1998. And this formula is formula for fair price of call option and if um, and first we can look at it as s minus k multiplied e to the power minus r t capital minus t liter. So the importance of this formula exactly in existing this coefficient n from d1 and n from d2, because without this coefficient, this formula was known before, many years ago. Mhm. And and we think what happens with the option price with this formula if one of these inputs parameters change, because you see that for this formula there are some parameters, 5 parameters. It is s as its initial price of stock, yes, k its strike price, um, T capital, it's time to maturity. Sigma is volatility, and we can compute volatility according to historical financial data. So it's interesting for us what happens with the option price if one of the input parameters change. And the answer for these questions gives Greeks, exactly Greeks. At this researches is called research of sensitivity of Black-Scholes model. Sensitivity. So it means how depends changing parameters on formula. Each I mean Greek letter, measures a different dimension to the risk in an option position. Because aim of the trader is to manage the degrees so of the risk are acceptable. So please have a look again on this equation. Its equation is called Black-Merton-Scholes equation. Yes, it's equation from previous lecture. But in this equation, you can see this. You can see this derivatives df to respect dt, the first order derivative, the second order derivative, yes, and derivative df respect to ds. But there are another derivatives, df to respect d sigma, for example, yes, for dr. So please have a look on this table. What are Greek? What does it mean? The first Greek delta. Delta means ds respect to ds. Yes, gamma. Then derivatives second order, vega, no, and so on. Yes, you see, 1, 2, 3, 4, 5 Greeks, 5 Greeks. Delta is the rate of change price with respect to price of underlying asset. So respect C, it's price of option, uh, respect to price of stocks. How depends changing in option respect to changing in S. Yes, first order and second order. Gamma is the rate of change delta with respect to the price of underlying asset. The vega measures the rate of change value with respect to volatility. Vega respect to volatility. Theta respect to time, and rho respect to interest rate. Yes. And now we as mathematicians need to know to find out how to derive a formula for delta. How we can find um, what we would like, the delta dc respect to ds. We would like this, respect dc respect to ds, or delta, yes, delta dc respect to ds. Mhm. Um, we know formula for c. For C, its formula for call option is Black-Scholes formula. We only rewrite is, and we need to find derivatives respect to S capital it's stock. And you see that in this term there is S, yes. So, but n its normal distribution from D1, but D1 depends on S2. Understand? So, um, so it is why first we would like to find derivatives from D1 and D2 respect to ds. So, what's expression for D1 from Black-Scholes formula? It's this expression. Yes, you see this expression. How we can find derivatives of this respect to s? To s, it's only coefficient constant, so we can rewrite this. After that, we should to find derivatives from a logarithm. What is derivatives from logarithm? Who remember? Only, for example, logarithm x. Mhm. If we have to logarithm x, how we can find derivatives from x? Ilaria, do you remember? Log it's ln. Ilaria, do you hear me?
Yeah, here I just can't really remember like.
ln.
X power to minus 1.
Yes, it's 1 divided by x, yes?
Yeah.
It's 1 divided it's 1 divided by x. But if we have not x, but for example f from x, so it will be 1 divided by f from x and multiplied f. Yes, it's chain rule. So in this case, if d1 is this expression and we would like this coefficient, so derivatives from logarithm, it is k divided by this, yes, k divided by this, k divided by s e to the power r t minus t liter, and multiplied by this expression respect to s. It will be 1 divided by k. 1 divided by k. And and so sorry. Um, after this here, it's s constant because it doesn't depend from s. So we have only one divided by s. You see. So its coefficient and derivatives from this, it's 1 divided by s. And derivatives from this, it's 0 because this expression doesn't depend on s. Yes, similar for this. It's the same. It is the same. So derivatives from d1 respect to ds equals derivatives d2 respect to ds, and this um, expression. So let's differentiate Black-Scholes formula. Black-Scholes formula. So it's product. So we need to find derivatives from s. It's 1 multiplied n. Yes, plus s multiplied derivatives from n respect to s, and derivatives from d1 respect to s. And if we have a look on this term, this is only constant, and we need to find derivatives from n uh, respect to s multiplied derivatives from d2 because d2 is function from s respect to ds. And this expression and this expression we found in previous steps, yes, and it will be 1 divided by s, 1 divided sigma square root from t capital minus t letter. So this we know, and we can write this big, after bracket, for example, after bracket, and in the bracket is this minus this. Yes. Only in this formula I wrote t minus t capital, but this I wrote only t, but maybe t capital minus t little, but it doesn't matter. So what is our expression? It is how we found derivatives ds respect to ds, this. But now we would like to show that all this is zero, equals zero, all this. And the answer will be only n from d1. For this, we mention that derivatives from n respect to s will be density of standard normal distribution. It is a distribution function, but if we can find its derivatives, its density. You know this from theory of probability. After that, we should do some manipulation. We would like to compute d1 plus d2 and d1 minus d2. So you remember this expression for d1, this expression for d2, and if we find sum of this, you see that this and this is the same. So it will be 2 times this expression, yes, but this and this are the same but with opposite signs, so it's 0. And our result d1 plus d2, this expression. After that, please find the difference between d1 and d2. This and this the same, so it's 0. And if from this we subtract this, minus minus, it will be plus, so it will be this plus this, or this, or 2 times this. So it's only sigma square root from t capital minus t little. Do you agree? Yes?
Yes.
So after that, we need to find difference of square from D1 and D2. And you know the formula for this. D1 plus D2 multiplied D1 minus D2. Yes? So we only multiplied this expression, and finally we have 2 log s divided by k plus 2r capital minus t. And it's only for follow. We would like only find d2 square divided by 2. It's from this, So it's only this minus d1 square divided by 2. And let's show this. So now we substitute expression from phi from D2 because it's density for standard normal distribution, and you know this expression. And after that, we substitute D2 square divided by 2 from this, you see. And if in D2 it will be log s divided by k plus r on this bracket minus, yes, and if we have e to the logarithm, it's according to property of logarithm, it will be only s, so the result will be such as this, so we find this. Oh, because of this. So we show that all this expression equals zero. In this formula because because this equals this. So only we have only n from d1, plus 0, yes. So, and the answer you can see in this table, So the first Greek, delta, what is? It's according definition, delta is derivatives c to respect to the s. So it's how change call price of call option respect to change stock price. And how we can find this? It is n, it's normal distribution from D1. And similar we can find for put option. And it will be or minus n from minus D1 or n from D1 minus 1. It's according property of normal distribution. After that, we can find gamma, and what's formula how we can find gamma, vega, and what's formula how we can find vega, theta, and rho. So all these formulas without proving, only delta with proving. Yes, only delta. Only delta. So we deals with Greeks, what is Greeks and how we can calculate. Please have a look table. And now about hedge and how hedge is connected with Greeks. A hedge is investment to reduce the risk. Normally, a hedge consists of taking and offsetting position in related securities, such as futures or options contract. And Let me explain this using some example. Example number one, naked and covered position. And you should understand what is naked and what is covered position. Maybe in future you will be connected with financial market, with traders operations. Maybe you will be you should write programs for option trading. Who knows? So, what's naked and covered position? Let's consider an example, the position of financial institution that has sold for 300,000 a European call option on 100,000 shares for non-dividend paying stocks. So understand, this institution has sold these European call options. In this moment, the stock price is $49. The strike price is 50. What does it mean? It's about this call option. So its strike price, its price which is written in call option, $50. The risk-free interest is 5% per 1 year, and stock price volatility is 20%. And time to maturity, this call option is 20 weeks. And we can compute that what is the past of year, 20 weeks, it's 0.3846. And expected return, for example, from the stocks is 13%. So all these are given, and we can write this. It is initial price of stock, it is strike price, it's interest rate, it's sigma volatility, T capital time to maturity, and mu, it's expected return. The Black-Scholes price of the option is 2.4. It's mistake. 2, not 24, 2.2, 2.4, and multiplied 100,000, it's 240,000. Yes, it is a fair price, but financial institution has sold for 300,000. It is more expensive than fair price. Yes, so this difference is 60,000. It is it's as a profit. Yes, as a profit. But this organization is faced with the problem of hedging risk. What does it mean? It means that um, this strategy to do nothing is sometimes referred to as naked position, and its strategy works well if the stock price at the time of maturity will be below 50. So at the end of the 20 weeks at the time of maturity, the call option then costs nothing, and it makes profit of 300,000. And the questions to you, why this call option then costs nothing? How we understand this phrase? Why the call option then costs nothing? What do you think? Who would like? Maybe Ilaria, no? maybe Vika. Are you here? Are you here?
Yeah,
Vika,
but I don't know.
We're here.
uh-huh. You're here, but you don't know, yes?
Yeah.
Yes. So again, one, if you buy call option, in what case you win? You can win. Do you know? For example, you buy call option with strike price 50, and at the end of 20 weeks, what should be market price for your win, and what for your loss? Vika, are you here? No?
Yes, I'm here.
You can understand this. You deal with financial mathematics. You buy call option with strike price 50. Yes? Yes. At
Yes,
the
so
end,
we have zero after 20 weeks. Because call option is S0 minus K, but it's a negative number, so we put zero. No?
well, please explain when we win and when we lose. If market price, mhm,
We
market
win
price
if K is less than S0.
less than 0. Why 0?
S.
S, with K less than S. Yes, what is S?
Yes. Yes,
What is S? What is S?
S is stock price.
Market stock price. Yes, thank you. So, yes, you're right. Um, if we bought call option, we strike price 50, and we are waiting, and at the end of the 20 weeks, we see that market price of stocks is more than K. For example, 60. So, hooray! You are win, and your profit is 60 minus 50. Yes, but if and for example 70, or your win 70 minus your profit is 20, and so on. But if the market price is less than K, for example 40, 45, 49, and 52, you lose because this difference or 0 or less than 0, negative. But if this difference negative, you don't realize this option, and your profit is 0. And if 50, your profit is 0 too. Understand? Everyone understand? No?
Yes.
Yes. Okay. So in our case, you see that K50, and mhm. and if the stock price below 50, you lose. Yes. Your profit uh, cost nothing. The call option cost nothing. So if we bought this option, we threw it into trash. Yes, but we already paid for this option. How much we paid for this option? How much? How much premium for this option? Premium was three, yes, because this organization sold for no three. It's one per option, but one shares, but 100,000. It's 300. So for three. Um, so and 100,000, 300,000. Understand? Financial institution has this money for because mm, because this organization sold it us. Yes, understand? Yes. So and it's great, but this naked position works less well if the call is exercised. So it's mean that the market price more than 50, for example 55 or 60. So this financial organization should give us this difference. If market price is 60, so difference 60 minus 50 is 10. But there are 100,000 of shares, so 10 multiplied multiplied 100,000, and it will be 1 million. Yes. So this financial institution must to give this money, But what she get from us only 300,000. Yes, understand this? Why this naked position is bad for financial institution? Now we learned this from side of financial institution. As an alternative to an acquisition, the financial sorry, institution had adopt a covered position. What's covered position? It's buying 100,000 shares immediately as soon as an option has been sold. In this case, if the stock price goes on over $49, our option is exercised. Yes, and this strategy works well because the financial institution gains this difference, 58 minus 49, and multiplied by this amount, and 900,000 its profit only on its stock trading. But this financial institution losses on its option. It is 58 minus 50 because strike price 50. Yes, strike price 50. But 49 it is price today. So and has 300,000 profit for option. So it is 900, it's profit on stocks minus its loss on options, and it's plus on options. It's plus that it's premium, but it's that the sum that should be returned. So it's profit 400,000. But but it is if the stock price goes up. But in other case, it could lead to a significant loss. significant loss. For example, if the stock price drops at $40, the financial institution loses 49 minus 40, and it's 900,000 on stock trading. But what it has, this financial institution, only 300,000 for premium of the options. Understand? So neither a naked position nor a covered position provides a good hedge. Maybe a good, if the assumption underlying the Black-Scholes formula hold, the cost of the financial institution should always be 240,000 on average for both approaches. But a good hedge would ensure that the cost is always close. So it's a theoretical price, and it is on this basis is stop loss strategy. Stop loss strategy is the situation illustrating on this chart, and it's key strike price, and if and it is strike price, and we know that the fair price, and the hedging procedure involves buying 1 unit of stocks as soon as its rise above car and selling as its price falls below car. You see that if more buy, if less sold, if more, and everyone we can compare. Buying the stock at time T1, selling at the time T2, buying at time T3, selling at time T2, and all that. A stop loss strategy doesn't work particularly well as a hedging scheme. Why? Because we have a possibility to buy or to sell at immediately at this moment at any amount. And most traders use more sophisticated hedging schemes. This involves calculating measures such as delta, gamma, and vega. And if you would like, you can open any site about option trading in Google or YouTube, and you can see about using these Greeks in option trading. So the delta is defined, I remember you, as the rate of changing of option price with respect to the price of underlying asset for stocks. And the delta hedging is an example of dynamic hedging. Dynamic hedging. So what is this, and how it was proved? It was proved by Black-Scholes-Merton model and analysis. Black-Scholes and Merton showed that it's possible to set up a riskless portfolio, and it was on the beginning of our lecture today. And what is riskless portfolio? Riskless portfolio is portfolio which consists of two positions. One position, it's minus delta. It's a position in option on a stock, in option, yes, an option, and with minus it means that sell, and plus one it position in stocks, and it means that buy. It is long position, and it's short position, and we know this formula. yes, we today derived this formula. So how we should to use this formula? Let's get back to the data from the example one. From example one, what is example one? Example one. Maybe it's this, yes. So we have initial price, strike price, interest rate, volatility, time to maturity, and mu. So everything we know. And and hedge is assumed to be adjusted weekly. Not every day, but every week, one time for a week. First value of delta is 0.522. How we can find this? According to this formula, we compute D1, yes, from this value, K, T sigma. After that, we can find normal distribution for D1. So we know delta call, and it's 0.522. Maybe have a look on this table. So week, yes, weekly. We adjusted weekly and hedge weekly. So, for example, week the begin the first week, and it's week 0, and stock price 49, and we computed delta, and delta is 0.522. It means that according to construct the risk portfolio, we should to buy stocks, and we should multiply to 100,000. Yes. This multiplied to this, its product this is result is 2,557.8. Yes, its cost of shares purchased. So we assume that we haven't any money. So this money we lend, we borrow, we borrow, we borrow. So our borrow this, and interest cost for a week. How much we should to repay it for 1 week is 2.5. 2.5, maybe it is this. You can read this as soon as the option is written. um, this sum must be borrowed to buy these shares at the price, yes, and interest rate is 5%, but it is interest rate for 1 year, but for 1 week it is this sum, yes, because we only multiplied by 7 days, 7 days from 365, and interest cost, we should multiply this sum to 557.8 by this value. So interest cost 2.5. Understand how we can get the first the first the first line. Yes, understand? No?
Yes.
Yes. So the second week, the price changed. Yes, have changed. And now it is 48.12. So we compute delta, we compute D1, after that and from D1, and it's 0.458. After that, we should find this difference between this delta Understand? So we should um, from this delta, current delta, destruct previous delta. And this value will be with minus, you see, yes, with minus, and it will be, the result will be 0, this result. So it and it's with minus, with minus, with minus. In this type table with minus, we only take in bracket, take in bracket. So it means that we should sell. Minus means that we should sell this amount of shares. Understand? So it was our cost of borrowing, but now this cost is less. Yes, because we give this money, and so this cumulative cost now is less. So it is to no, from this we should destruct this and this and result this. Yes, and after that we multiplied this value on the interest rate for week, and what is this sum? And maybe we can read about this on next slide. Cumulative cost to repay at the end of the first week is this. Interest cost at the end of the first week is this. Yes, and so on. So you understand that every week when we calculate delta, we make a decision to buy or to sell stocks, and how much, not all stocks you should to buy or to sell, how in this strategy. But in this strategy, if the price more or less, so we buy all stocks, or we sell all stocks. But in this case, we calculate how much amount of stocks which we should to buy or to sell. Understand? So what we have at the end of the 20 weeks. At the end of 20 weeks, you see that delta is equals 1, yes? And it will be in case if stock price will be more than strike price. Strike price is 50, you understand, but it's more than strike price, so the delta tends to 1. And we can compute how much we buy and how much we sold stocks. So 52 plus 19 plus 9 plus 8 plus 11 plus 12 plus 4. So we should to find sum all shares with plus, and after that all with minus. And the result is that during 20 weeks, the investor bought 160 and 1,500 and sold this amount shares. So at the end of the period, he owns 100,000 shares. And now we need to calculate profit in stock trading, and it's 500 and 500. What is your calculate? And if we have that he owns 100 shares, and on this moment the price of stock 57.25, so we should multiply. Yes, understand? This value and multiplied 100,000. Multiplied 100. Yes, and it's this sum, you see. So it's your value is clear, and minus this value, it's cumulative cost. So it's as our cash we have plus minus. So the difference is 461 and 700. So it's profit in a stock trading. But you remember that if we construct riskless portfolio, so yes, and he must give out this value because this is difference between market price at the end of 20 periods, 20 weeks, and this is its strike price, and this financial institution must to give out this different for everyone who bought this call option. Yes, but it was 10,000. So it's loss, but he earns premium. So loss is this, and total net profit is 36 and 1,700. Understand?
Shouldn't it be 100,000 there?
Please, about
This row, as holder of call options, he must give out, and
yes.
we multiply by 10,000, but it should be 100,000, no?
mm, I can explain that. Yes.
Yeah, I think where we have 10,000, I think we should have 100,000. 10 is missed.
Not 10,000, but maybe it's mistake. 100. No,
Yeah.
100. Yes, you're right. Um, yes, but it's interesting. And this case we can call as that. No, in this case, we can say that option closes out of the money. And there are another situation where the market price will be less than strike price. Yes, you remember strike price 50, but in this case it is 80, 48. Yes, and this table is constructed the same for every week we compute delta, and after that we can difference between current delta and previous delta, and we make decision about to buy or to sell the shares, and so on. And what we have, you see that delta tends to zero. Option isn't exercised, because it's call option, but this market price less than strike price, so call option isn't exercised. Financial institution has a profit premium 300,000, and at the end of period, during the period, the financial institution bought 126,000 and sold 126. So he owns zero shares. In the previous table, yes, in this analysis, the institution owns 100,000 shares because it's profitable. But in this case, zero shares, and but his loss is this sum in stock trading, because because this financial institution borrowed money, bought money, sold money, yes, and repaid for borrowing, and it was 256 1,600, and you see that this sum is close to fair price, because fair price was 2.4. It's very close. And the net profit from hedging is this, because the financial institution sold call option for this price. So summary: if the assumption underlying the Black-Scholes formula hold, the cost of the financial institution should always be this sum. It's a fair price on average for both approaches. But on any one occasion, the cost is liable to range from 0 to over this. A good hedge would ensure that the cost is always close to this. And you see that it is approximately close. And that's all. Maybe you have any questions, and after that you need to answer the test about this lecture. Have you any questions? And I would like to add that we will have individual tasks And I will explain again how to do this individual task, and this individual task will include hedging too and constructing this table too, but it will be on practice lesson.
Okay.
Have you any questions? No? So thank you for attention. I end recording.